For this discussion, we will be tackle about higher order of derivatives. But before that, we will first recall the different theorems of differentiation. So we have 6 theorems. The first one is constant rule. So here, the derivative of every constant is equal to 0. For example, the f of x is equal to 50. So, the derivative of this function is equal to 0. Why? Since 50 is a constant, and by applying the constant rule, the derivative of a constant is equal to 0. So, the derivative of this function is equal to 0. So, the second one is the power rule. So, here, we have an example equation which is x raised to 2 or x squared. So, we will derive this by subtracting 1 to the exponent, which is 2. Then 2 minus 1 is equal to 1. Then the exponent 2, we will multiply it to the coefficient of the variable x, which is 1. So 2 times 1 is equal to 2. So the answer is 2x raised to 1, or is equal to 2x. The third theorem is constant multiple rule, wherein this is the formula or the general definition of a constant multiple rule. For further explanation, for you to understand, for example, find the derivative of f of x is equal to 4x raised to 5. So first, we will multiply the exponent 5 to the coefficient of the variable x, which is 4. So is equal to 5 times 4 is equal to 20. So the second one is we will subtract 1 to the exponent 5, which is 5 minus 1, or x raised to 5 minus 1 is equal to x raised to 4. So the derivative of this function is equal to 20x raised to 4. So the fourth rule is the sum and difference rule of differentiation. So here, for example, we have a function 3x raised to 5 plus 4x raised to 4. So first, we will derive the 3x raised to 5, then we will also derive 4x raised to 4. So by that, we apply the constant multiple rule in 3x raised to 5. So we will multiply the exponent 5 to the coefficient of x, which is 3. So 5 times 3 is equal to 15. Then we will deduct 1 to 5. So 5 minus 1 is equal to 4. So it will become 15x raised to 4 is the derivative of 3x raised to 5. Then we will be add the derivative of 4x raised to 4, which is we also apply here the constant multiple rule, wherein we will multiply the exponent 4 to the coefficient of variable x, which is 4. So 4 times 4 is equal to 16. Then we will subtract 1 to 4, which is 4 minus 1. Then it will become 3. So the derivative of 4x raised to 4 is equal to 16x raised to 3. So the derivative of the equation 3x raised to 5 plus 4x raised to 4 is equal to 15x raised to 4 plus 16x raised to 3. So the fifth theorem or rule is the product rule. Here, for example, we have an equation 3 minus x squared times x plus 4. So we have formula here wherein f of x times the derivative of g of x plus g of x times the derivative of f of x. So we will note that 3 minus x squared is to be f of x, then x plus 4 is to be g of x. So first, what is f of x? So our f of x is 3 minus x squared. Then the derivative of g of x. Since the g of x is x plus 4, or x plus 4 is first we derive x. What is the derivative of x? The derivative of x is 1. So we will write here. Then the derivative of 4 is 0 since it is a constant. We will no longer put that on the given equation. So we will add g of x, which is x plus 4, then the derivative of f of x. So the derivative of 3 is 0 since it is a constant. Then we will multiply the derivative of negative x raised to 2, which is we will multiply the exponent 2 to the coefficient of variable x, which is 1. So 2 times negative 1 is negative 2. Then we will subtract 2 into 1. So 2 minus 1 is equal to x. So the derivative of 3 minus x squared, or the f of x, is equal to negative 2x. Then we will do the distributive property, and the answer for this is equal to negative 3x raised to 2 minus 8x plus 3. So the sixth rule is the quotient rule. So for example, we have a formula here, which is u of x over b of x, or equal to the u prime of x times b of x minus u of x times b prime of x over b of x squared.
Our discussion is all about higher order of derivatives. Higher order derivatives are derivatives higher than first derivative. So first, we will familiarize to the different notations that we will use. First is f prime of x is the same as y prime and dy over dx. And for the second derivative is f double prime x is the same as y double prime and d is raised to 2 y over dx raised to 2. And if we will find the more than fourth derivative of a function, we will use f raised to n x is the same as y raised to n and d raised to n y over dx raised to n.
Example: find the first, second, and third derivative of each of the following. Example number 1. Y is equals to x to the fourth power plus x cubed minus 9. So we will find the first derivative. The first derivative of x to the fourth power is 4x cubed, where we multiply our exponent to the coefficient of x, which is 1. So it is equal to 4. And we subtract the exponent to 1. So the exponent will become 3. Same process in x cubed. 3 times 1 is equals to 3, and 3 minus 1 is equals to 2. So it will become 3x squared. Negative 9 is a constant, so the derivative of a constant is 0. So the first derivative will be y is equals to 4x cubed plus 3x2. Next is second derivative. So 3 times 4, it is 12, and 3 minus 1 is 2. So the second derivative is 12x squared plus 3x times 2 is equals to 6, and 2 minus 1 is equals to 1. So it will become 6x. Therefore, the second derivative is 12x squared plus 6x. In our third derivative, 2 times 12 is 24. The exponent is 2 minus 1. So the exponent become 1 plus the derivative of 6x. X is 6 because x is equals to 1. So 6 times 1 is equals to 6. So our third derivative is 24x plus 6. So example number 2. Y is equals to 3x cubed minus 2x squared minus 4. We will use the power rule, first derivative. 3 times 3 is equals to 9, and 3 minus 1 is equals to 2. So it's 9x square minus 2 times 2 is equals to 4, and subtract exponent 2 minus 1 is equals to 1. So it will become 4x, and the derivative of a constant is 0. So negative 4 will become 0. So our first derivative is 9x squared minus 4x. For second derivative, 9 times 2 is equals to 18, and subtract 1 to the exponent. It will become 1, and 4 times 1, which is the x. So 4 times 1 is equals to 4. So our second derivative is 18x minus 4. And our third derivative is 18 because 18 times 1 is equals to 18, and the derivatives of negative 4, which is a constant, is 0. So our third derivative is 18 minus 0 is equal to 18. F of x is equal to the quantity of 2x plus 3 raised to 4. We will use the chain rule. So first derivative is 4 times the quantity of 2x plus 3 and subtract 1 to the exponent. So it will become 3, and get the derivative of the 2x plus 3, which is 2. So our first derivative is 4 times the quantity of 2x plus 3 raised to 3 times 2, then simplify 4 times 2 equals 8, and copy the quantity of 2x plus 3 raised to 3. In our second derivative, we multiply 3 to 8 equals to 24, and copy the quantity of 2x plus 3 and subtract the exponent. 2 minus 1 equals 2, times the derivative of 2x plus 3, which is 2. Then simplify 24 times 2 equals 48, and copy the quantity of 2x plus 3 raised to 2. Next is third derivative. 48 times 2 equals to 96, and subtract the exponent to 1. It will become 1 times 2. Then simplify 96 times 2 is equals to 192, and copy 2x plus 3.
Example number 4. F of x equals the quantity of x squared plus 2 raised to 3. So before I will discuss the answer of number 4, kindly answer this on your own, and we will check it later. I'll give you 1 minute to answer. You may start now. So I hope you are done answering. We will now discuss the answer.
Here, we get the first derivative of the function by multiplying the exponent 3 to the coefficient of the quantity x squared plus 2, which is 1. So it will become 3 times the quantity of x squared plus 2. Then we will subtract 1 to the exponent 3, which is 3 minus 1 is equal to 2. Then we get the derivative of x squared plus 2, which is 2x, because x squared, the derivative of x squared is equal to 2x, because 2 minus 1 is x, then plus the derivative of 2, which is a constant, so 0. So 2x plus 0 is equal to 2x. So the first derivative is 3 times the quantity of x squared plus 2 raised to 2 times 2x. Then we simplify it by multiplying 2x times 3 is equal to 6x times the quantity of x squared plus 2 times or raised to 2. So now we will get the second derivative of 6x times the quantity of x squared plus 2 raised to 2. So first, we will get the chain rule of x squared plus 2 raised to 2, which is we will multiply 2 to the coefficient of x squared plus 2, which is 1. So then we will get the derivative of x raised to 2 plus 2, which is 2x, because the derivative of 2 is 0. Then we will add the x squared plus 2 raised to 2, which is we only copy from the given first derivative. Then we get the derivative of 6x, which is 6. Then we now simplify by multiplying 2 to the 2x, so it will become 4x. Copy the quantity of x squared plus 2. Then we add the x squared plus 2 raised to 2 by expanding it because it is a special product. And we will get now x raised to 4 plus 4x raised to 2 plus 4 by square the first term, x raised to 4 plus x squared times 2, which is 2x raised to 2 times 2, which is 4x raised to 2. Then square the last term, which is 2 times 2, which is 4. Then we will bring down 6. Then we will now simplify again by distributive property, which is we will distribute 4x times x squared, which is it will become 4x raised to 3. Then 4x times 2, it will become 8x. Then we will distribute also 6 times x raised to 4. Then it will become 6x raised to 4. Then 4x raised to 2 times 6, which is equal to 24 times or 24x raised to 2 plus 6 times 4 is equal to 24. After that, we will distribute 6x to the quantity of 4x raised to 3 plus 8x. So by that, we will get 6x times 4x raised to 3 is equal to 24x raised to 4, because we will add the exponent of x, which is 1 and 3. So it will become 4. Then we will multiply 6x times 8x, and it will equal to 48x squared, because x have the coefficient of 1 or exponent of 1. Then it will add, it will equal to 1 plus 1 is equal to 2. Then copy or bring down 6x raised to 4 plus 24x raised to 2 plus 24. Then we will now combine the same like terms, which is 24x raised to 4 plus 6x raised to 4, which is we will add 24 plus 6, it will give 30x raised to 4. Then we will add also 48x raised to 2 plus 24x raised to 2, which is equal to 72x raised to 2, plus we will bring down 24 since there is no other constant in the equation. So the second derivative now is equal to 30x raised to 4 plus 72x raised to 2 plus 24. Or equal, we will now simplify it because there is similar terms, which is 6. We will simplify it by 6 times the quantity of 5x raised to 4. Why 5? Because 30 divided by 6 is equal to 5. Then copy the x raised to 4. Then 72 divided by 6 is 12. So copy x raised to 2 plus 4, because 24 divided by 6 is 4. So the second derivative in simplest form is equal to 6 times 5x raised to 4 plus 12x raised to 2 plus 4. So that is the second derivative. So in getting the third derivative, we multiply the exponent 4 to the coefficient of x, which is 30. So 4 times 30 is equal to 120. Then we subtract the exponent 4 into 1. So 4 minus 1 is equal to 3. So the derivative of 30x raised to 4 is equal to 120x raised to 3. Then plus, we will now also derive 72x raised to 2, which is, we multiply the exponent 2 to the coefficient of x, which is 72. So 2 times 72 is equal to 144. Then we subtract 1 to the exponent, which is 2. So 2 minus 1 is equal to 1, or simply x. Then the derivative of 24, which is a constant, is equal to 0. So the third derivative is 120x raised to 3 plus 144x. So we simplified it because there is a common term between 120 and 144, which is 6. So in simplest form, the third derivative of f of x is equal to 6, the quantity of 20x raised to 3, because 120 divided by 6 is 20. Then copy the x cubed plus 144 divided by 6 is equal to 24. So and then copy x, and then the final answer is 6 times 20x cubed plus 24x. Example number 5. Y equals 5 cosine of x plus 4 over the quantity of x plus 6 raised to 2 minus 3x. So we will now transform the fraction 4 over the quantity of x plus 6 raised to 2 into exponential. So it will become 4 times x plus 6 raised to negative 2. So we will now get the first derivative of the function, which is 5. The derivative of cosine of x is negative sine x plus 4 times the exponent of the quantity x plus 6, which is negative 2, times the quantity of x plus 6 raised to negative 3. Negative 3 because negative 2 plus negative 1 equals to negative 3. And the derivative of negative 3x is negative 3. So we will now simplify 4 times negative 2, which is negative 8. Then copy the quantity of x plus 6 raised to negative 3. Then copy the negative 3 and distribute the 5 and negative sine x, which will become negative 5 times sine of x. For the second derivative, negative 8 times the negative 3, which is the exponent of the quantity x plus 6, and copy the quantity of x plus 6, and negative 3 plus negative 1 is equal to negative 4, which is the exponent. Then negative 5, the derivative of sine x will become cosine x. We will now simplify the second derivative, which is negative 8 times negative 3 will become 24. Copy the quantity of x plus 6 raised to negative 4, and then copy also the negative 5 times cosine x. For the third derivative, we will multiply 24 to negative 4, which is the exponent of x plus 6. So it will become negative 96, then times x plus 6 raised to negative 5, which is negative 4
plus negative 1 is equal to negative 5. Then the derivative of cosine x is negative sine x. So we will we will multiply it to negative 5. So it will become positive 5 sine x. So our third derivative is negative 96 times the quantity of x plus 6 raised to negative 5 plus 5 sine x.
So we are now done discussing about higher order of derivatives. I hope you all understand and grasped this lesson. So for your exercises, find the first and second and third derivative of each of the following. Number 1, y is equal to sine of x minus 7 over x plus 9 raised to 5 minus 14x. You can use in exercise number 1 the example number 5, and for number 2 is the function of x is equal to the quantity of x raised to 4 plus 18 raised to 6. You can use example number 3. I hope you are good in this lesson and do more exercises so that you will become excellent in this topic. Thank you and God bless.